the previous class we saw problems on DIT FFT algorithm. So we completed how to find out DFT using DIT FFT algorithm as well as how to find out IDFT using DIT FFT algorithm, both on 4-point as well as 8-point DFTs. So today we will start what is meant by DIF FFT algorithm, and let us see few problems on DIF FFT algorithm. So if we want to derive this algorithm, that is DIF FFT algorithm, what we do is we choose the selection such that the value of L is equal to 2 and the value of M is equal to n by 2, which leads to the storage of data in column wise. Okay. So what we do is we apply divide and conquer approach in order to derive this particular DIT FFT algorithm. So what we do here is we split the summation of DFT into two summations such that the first summation will contain the beginning n by 2 samples, data samples, and the second summation will contain the last n by 2 data samples. So now let us see how we are deducing this particular algorithm with the help of divide and conquer approach. So for that what I will do is I will take the equation of DFT which we have studied. So we know DFT is given by x of k, which is equal to summation n ranges from 0 to n minus 1 x of n into omega n to the power of kn, where the range of k is from 0, 1 up to n minus 1. Okay. What I said, we are dividing this summation into two summations such that the first summation will contain how many samples? N by 2 data samples, and the second summation will contain last n by 2 data samples. So how we can do that? So if I consider the value of n is equal to 8, so the samples which we have is 0, 1, 2, 3, 4, 5, 6 and 7. Okay. So we know this is the 0th sample and this is n minus 1 sample. So 8 minus 1 is 7. So if in order to divide this particular summation into two equal halves, so what I do is I group these terms and I group these terms. Okay. Initially the lower limit of first summation starts from 0, and what will be the upper limit? The upper range should give us the indexing of 3. For that what I need to do? So it is nothing but n by 2 minus 1. Okay. So what is the value of n? The value of n is 8. 8 by 2 is 4. 4 minus 1 is 3. So do we get 3? Yes. So for this the limit will be n by 2 minus 1. Similarly, I need to check what is the lower limit of second summation, because we have the upper limit. So it should start from the 4th sample, the second summation. So in order to get it as 4, the value of n is 8. So how I can make it as 4? It is nothing but equal to n by 2. So if I do it as n by 2, so the value of n is 8, 8 by 2 is 4. So we get this particular value, that is 4. Now let me rewrite this particular summation into two equal halves. So looking here, this contains n by 2 data samples and this also contains n by 2 data samples. So as I said in the beginning of this class. So if I rewrite this equation, x of k will be equal to summation. What is the lower limit of first summation? It is from 0, and the upper limit is n by 2 minus 1. So rest of the things remains as it is. X of n into omega n to the power of kn. Okay. Plus summation n ranges from, what is the lower limit of second summation? It is n by 2, and the upper limit is n minus 1. Okay. Rest of the things remains as it is, that is x of n into omega n to the power of k. Hope it is clear how I divided this summation into two summations and how I took lower and upper limits for both the summations. Now let us concentrate on the second summation part. So let us take the substitution for n. So if I take the substitution for n as n plus n by 2, the limits also changes. So if I write the equation directly, so I can write it as x of k, which is equal to summation n ranges from 0 to n by 2 minus 1 x of n into omega n to the power of kn plus summation n ranges from 0 to n by 2 minus 1 x of n plus n by 2 into omega n to the power of k into n plus n by 2. So what I did, I took the substitution for n in the second summation. If I do so, the limits also changes. So I have written it directly. Okay. So now let me write this twiddle factor term separately. So if we do so, x of k will be equal to summation n ranges from 0 to n by 2 minus 1 x of n into omega n to the power of kn plus summation n ranges from 0 to n by 2 minus 1 x of n plus n by 2 into omega n to the power of kn into omega n to the power of kn by 2. Okay. Now this particular twiddle factor term is not at all varying with respect to omega n. So let me move this twiddle factor term outside the second summation. So if we move that outside the summation, the equation will be summation n ranges from 0 to n by 2 minus 1 x of n omega n to the power of kn plus this term I am moving it outside. So omega n to the power of kn by 2 into summation n ranges from 0 to n by 2 minus 1 into x of n plus n by 2 into omega n to the power of kn. Now let me simplify and see what am I going to get for this particular twiddle factor term. That is, we know that omega n to the power of kn is nothing but equal to e power minus j 2 pi kn by n, correct? The standard term. Now which value should I find out? The value for this particular twiddle factor term. So let me rewrite that. That is omega n k into n by 2. So instead of small n, I have it as capital N by 2. Let me replace and write. So e power minus j 2 pi k n by 2 divided by n, which can be written as e power minus j 2 pi k n by 2n, correct? So what can I do? I can cancel 2 and 2, n and n. So we are left out with e power minus j pi to the power of k. So what is e power minus j pi? So we know it is nothing but equal to cos pi minus j sin pi. So cos pi is minus 1, sin pi is 0. So the imaginary term goes. So what we are left out with? We are left out with minus 1 to the power of k. So instead of omega n to the power of kn by 2, I can write it as minus 1 to the power of k in this particular equation. So let me substitute in this equation. Therefore, x of k will be equal to summation n ranges from 0 to n by 2 minus 1 x of n into omega n to the power of kn plus, so instead of which term? Omega n to the power of kn by 2, I am replacing it with minus 1 to the power of k. So you get this. So rest of the things I will rewrite it as it is, that is summation n ranges from 0 to n by 2 minus 1 x of n plus n by 2 into omega n to the power of kn. So this was a simplification which I did. Now looking into both the summation, the limits of summations are same and the twiddle factor multiplied to both the terms are same. So I can take those two as common factor. So if I take those two as common factor, x of k will be equal to summation n ranges from 0 to n by 2 minus 1 into, so only x of n will be left out in the first term plus, so I will rewrite it as it is, minus 1 to the power of k. In the second term we get only this term, that is x of n plus n by 2 into, what is the common twiddle factor term? That is omega n to the power of kn. So now what I need to do, I need to decimate this particular thing with respect to even and odd numbered samples so that I can divide n point to n by 2 and n by 2. Okay. So for that what I will do is, let us take a substitution for even, let us take substitution for odd also, that is, let k be equal to 2r for even. Okay. If k is equal to 2r for even, let me term this equation as equation 1 in equation number 1. So let us see what happens to equation 1, that is x, wherever we have k, I need to replace it with 2r, x of 2r which is equal to summation n ranges from 0 to n by 2 minus 1 into x of n plus minus 1 to the power of 2r. I have k here, instead of k I am taking it as 2r into x of n plus n by 2 into omega n to the power of 2rn. Okay. So in the next step what let us do is, let us simplify this twiddle factor and let us rewrite. And let us see what happens to this minus 1 to the power of 2r term. Now what let us do is, so I got this equation, now let me try to simplify this one. Okay. That is, we know that omega n to the power of kn is equal to e power minus j 2 pi kn by n. So instead of kn what we have omega n to the power of 2rn. So that is omega n to the power of 2rn. So if I rewrite this in terms of exponential term, I can write it as minus j 2 pi, instead of kn I have it as 2rn. Let me replace that, 2rn divided by n. Okay. So if I rewrite this, I can write this as e power minus j 2 pi rn divided by n by 2. Okay. Now if I write this in terms of twiddle factor, so we can write it as omega to the power of rn n by 2. Okay. So this is the one substitution which we can take. Similarly, so for all values of r, what happens to minus 1 to the power of 2r? So if I take r as 0, minus 1 to the power of 0 is 1. Similarly, if r is equal to 1, minus 1 to the power of 2 is also equal to 1. So whichever value of r you take, the value of minus 1 to the power of 2r will tend to 1. So that is also one substitution which we can take, that is, but for all r, minus 1 to the power of 2r is equal to 1. So let us substitute these two things in this equation. So if I substitute, x of 2r will be equal to summation n ranges from 0 to n by 2 minus 1 x of n Instead of minus 1 to the power of 2r, I can substitute it as plus 1 into x of n plus n by 2 into, instead of omega n to the power of 2rn, I need to substitute it as omega n by 2 to the power of rn. So, omega n by 2 to the power of rn. Okay. So, instead of this entire term, I will take it as g of n and I will rewrite, that is x of 2r will be equal to summation n ranges from 0 to n by 2 minus 1 g of n into omega n by 2 to the power of rn, where g of n is equal to x of n plus x of n plus n by 2. So, this is the first thing which we deduced with respect to even, that is when k is equal to 2r for even in this equation we got this particular equations. Now, the same thing I need to do for odd. Let k be equal to 2r plus 1 for odd in equation 1. So, let this be the second substitution with respect to odd. Okay. So, in this equation wherever I have k, I need to replace it with 2r plus 1, that is x of 2r plus 1 will be equal to summation n ranges from 0 to n by 2 minus 1 x of n plus minus 1 to the power of 2 r plus 1 into x of n plus n by 2 into omega n to the power of 2r plus 1 into n. Okay. Now, let us try to simplify this. So, if I simplify this, the first thing which I can do is I can write this omega term separately. So, if I do so, the equation will be x of 2r plus 1 which is equal to summation n ranges from 0 to n by 2 minus 1 into x of n plus minus 1 to the power of 2r plus 1 into x of n plus n by 2 into omega n to the power of 2rn into omega n to the power of n. Okay. So, previously we saw omega n to the power of 2rn is nothing but equal to omega n by 2 to the power of rn. So, I can write it directly, but omega n to the power of 2rn is equal to omega n by 2. Okay. Similarly, what happens to this entire term? If r is equal to 0, it becomes minus 1 to the power of 1. What is minus 1 to the power of 1? It is nothing but equal to minus 1. If r is equal to 1, the power will be 2 plus 1 which is equal to 3. So, minus 1 cube is also equal to minus 1. So, what is the conclusion which we can make? So, for all values of r, minus 1 to the power of 2r plus 1 will tend to minus 1. So, let me take the second substitution as that is for all r, minus 1 to the power of 2r plus 1 is equal to minus 1. So, let us substitute these two things in this equation. Therefore, x of 2r plus 1 will be equal to summation n ranges from 0 to n by 2 minus 1 x of n. Instead of minus 1 to the power of 2r plus 1, I need to substitute it as minus 1. Minus 1 into this term gives us minus x of n plus n by 2 into omega n by 2 to the power of rn into omega n to the power of n. Okay. Now, instead of this term, let me take a substitution. So, let the substitution be x of 2r plus 1 which is equal to, I will write summation as it is 0 to n by 2 minus 1. So, which terms? So, this term as well as this term. So, this term together, this one and this omega term. So, let us take it as h of n. So, and the remaining omega term is omega n by 2 to the power of Rn, where what is h of n? H of n is nothing but equal to x of n minus x of n plus n by 2 into omega n to the power of n. So, this is the first decimation, that is we divided the first thing. Now, what I need to do? I need to take the even term, that is x of 2r, and again I need to deduce that. So, let us see, and at last let us see how to draw the butterfly structure for DIF FFT algorithm. This was the equation for x of 2r, and what is the substitution which we took for this? We took it as g of n. So, let me write that. So, summation n ranges from 0 to n by 2 minus 1 g of n into omega n by 2 to the power of Rn. Now, I need to divide this into equal halves, that is 2 summation. So, if I divide this into 2 summation as we did in the beginning, so this will be equal to summation n ranges from 0 to n by 4 minus 1 g of n omega n by 2 to the power of Rn plus summation n ranges from n by 4 to the power of n by 2 minus 1 g of n into omega n by 2 to the power of Rn. So, how we got this limit? So, initially we divided the entire 8-point DFT into 2 equal halves such that the first summation contains n by 2 samples. So, I will write only the first part, that is 0, 1, 2 and 3. The limits for this was 0, the limits for this was n by 2 minus 1. So, we assume the value of n was equal to 8. So, 8 by 2 is 4, 4 minus 1 is 3, you got this one. Now, how I divided this? I am dividing that into 2 summation, this single summation into 2 summation such that it contains equal number of samples. Okay. So, the lower limit of first summation is 0, correct. So, now I need to get the indexing as 1 for the upper limit. So, what will be the upper limit? So, the upper limit will be n by 4 minus 1, correct. What is the value of n? N value which we have taken is 8. 8 by 4 is 2. 2 minus 1 is 1. We are getting it as 1. So, the limit for first summation which I took is from 0 to n by 4 minus 1. Similarly, the second summation has the upper limit n by 2 minus 1. I have written it already. What should be the lower limit? So, I need to get it as 2. In order to get that as 2, I need to divide n by 4. So, 8 by 4 is nothing but equal to 2. So, the lower limit of the second summation will be equal to n by 4. So, this is how I deduce the single summation into 2 summations, and this is the way how we can write the limits for that particular summation. So, in the next step what let us do is, let us take substitution for n only for the second summation. If we do so, what happens? The limits also changes. So, let me write the equation directly how we get the limits if I take the substitution for n. If I rewrite the equation by taking the substitution for the second summation, so x of 2r will be equal to summation n ranges from 0 to n by 4 minus 1 g of n into omega n by 2 to the power of Rn plus summation n ranges from 0 to n by 4 minus 1 g of n plus n by 4 into omega n by 2 to the power of r into n plus n by 4. Now, in the next step, let me write the summation twiddle factor term separately. So, if I write that, the equation will be summation n ranges from 0 to n by 4 minus 1 g of n into omega n by 2 to the power of Rn plus summation n ranges from 0 to n by 4 minus 1 g of n plus n by 4 into omega n by 2 to the power of Rn into omega n by 2 to the power of R into n by 4. Okay. Again, looking into this twiddle factor term, it is not ranging with respect to n. So, I can take it outside the summation and write. So, if I rewrite this equation, I can write it as x of 2r will be equal to summation n ranges from 0 to n by 4 minus 1 g of n into omega n by 2 to the power of Rn plus omega n by 2 to the power of R into n by 4 into summation n ranges from 0 to n by 4 minus 1 g of n plus n by 4 into omega n by 2 to the power of Rn. Okay. Now, I need to find out what is this value. So, let me do so. But what we know, omega n to the power of kn is nothing but equal to e power minus j 2 pi kn by n, the standard equation. So, which value I need to find out? I need to find out the value for this, that is omega n by 2 to the power of R into n by 4. This will be equal to e power minus j 2 pi R into n by 4 into 2 by n. Correct? So, what I can do? I can cancel n with n, 4 with 4. So, what we are left out with? We are left out with e power minus j pi to the power of R. So, what is e power minus j pi? So, it is nothing but equal to cos pi minus j sin pi, which is nothing but equal to minus 1. So, this is equal to minus 1 to the power of R. Okay. So, let us tabulate in the equation, and also let us take summation n ranges from 0 to n by 4 minus 1 and omega n by 2 to the power of Rn as a common factor in the single step. That is x of 2r will be equal to summation n ranges from 0 to n by 4 minus 1 into g of n. So, instead of this term, I need to substitute it as minus 1 to the power of r. In the second term, we get g of n plus n by 4 into omega n by 2 to the power of Rn. Now, we deduce this equation. Now, let us take the substitution for r, that is, let r be equal to 2l for even. So, let us term this as equation 2 in equation 2. If so, what happens? X of 2r will be equal to summation. Instead of r, I need to substitute it as 2l. 2 2s are, it becomes 4. So, it is x of 4l, which is equal to summation n ranges from 0 to n by 4 minus 1 into g of n plus minus 1 to the power of 2l into g of n plus n by 4 into omega n by 2 2l n. Okay. Now, let me find out what is the value for this and what is the value for this term also. So, but omega n by 2 to the power of 2 ln will be equal to, I am writing this directly. So, e power minus j 2 pi into 2 ln divided by n by 2. Okay. So, I will move this term to the denominator part. So, I can write it as e power minus j 2 pi ln whole divided by n by 4. So, if I write this in terms of twiddle factor, I can write it as omega n by 4 to the power of ln. So, instead of this, I can replace it with this. Now, I need to find out the value for minus 1 to the power of 2l. So if L is equal to 0, minus 1 to the power of 0 is 1. So for all values of L, minus 1 to the power of 2L will be equal to 1. So let us substitute these two things in this particular equation. Therefore, x of 4L will be equal to summation n ranges from 0 to n by 4 minus 1 into g of n plus g of n plus n by 4 into omega n by 4 to the power of ln. Now, instead of this entire term, let me take one more substitution. So, if I rewrite that, x of 4L, this will be equal to summation n ranges from 0 to n by 4 minus 1. So, let me take that as a of n into omega n by 4 to the power of ln. So, where a of n is nothing but equal to g of n plus g of n plus n by 4. So, this is how we decimate the given sequence in DIF FFT algorithm. So, what we need to do, again you can continue the derivation by substituting the value for r as r will be equal to 2L plus 1. So, what happens? So, let r be equal to 2L plus 1 in equation 2. So, let me write the equation directly. So, it becomes x of 4L plus 2, which is equal to summation n ranges from 0 to n by 4 minus 1 g of n minus g of n plus n by 4 into omega n by 4 to the power of ln into omega n by 2 to the power of n. Now, instead of this term and this term, let us take a substitution, that is summation n ranges from 0 to n by 4 minus 1. Let me take it as b of n into omega n by 4 to the power of ln, where b of n is nothing but equal to g of n minus g of n plus n by 4 into omega n by 2 to the power of n. So, this is how we apply divide and conquer approach to derive DIF FFT algorithm. Now, with the help of this derivation, let us see how to construct the butterfly structure for DIF FFT algorithm. Now, let us see how to draw the butterfly structure. So, what I have done is I am assuming the value of n is equal to 8. So, if n is equal to 8, if I express this in the form of 2 power v, I can write this 8 as 2 cube. So, the value of v which we are getting is 3, which tells that it should have 3 stages. So, now let us see how to draw the first stage. From the derivation, this were the two things which I got. Next, we got these two equations. So, first let me take this equation and let me show how to draw the first stage. So, this is with respect to second stage. So, in DIF FFT algorithm, the input will be in normal order. So, I will write the input, that is x of 0, x of 1, x of 2, x of 3, x of 4, x of 5, x of 6 and x of 7. Now, let us take the substitution, that is let n be equal to 0. So, what happens to g of 0? So, g of 0 will be equal to x of 0 plus x of 0 plus, what is the value of n which I have assumed? It is 8. 8 by 2 is 4. So, this is nothing but equal to x of 0 plus x of 4, correct? So, in order to get g of 0, what I need to combine? I need to combine the data of x of 0 and x of 4. So, this is x of 0 and here is my x of 4. So, here you get g of 0. So, I am bringing this and I am making that to meet at that particular point, and the second data is x of 4. So, from here I will join to this point. So, we get g of 0. Okay. Similarly, let n be equal to 1. So if n is equal to 1, what happens to g of 1? This will be equal to x of 1 plus, this becomes x of 1 plus 4. So x of 1 plus 4 is x of 5. So in order to get g of 1, which signals or data should I combine? I need to combine x of 1 and x of 5. So from this particular thing I am getting x of 1, and where is x of 5? It is here. So I will take this signal and I will make that to meet at this point. This gives us g of 1. Okay. Similarly, let n be equal to 2. So if n is equal to 2, what happens? G of 2 will be equal to x of 2 plus x of 6. Okay. So n is 2, 2 plus 4 is 6. So I need to combine x of 2 and x of 4. So this is x of 2 and this is x of 6. So I need to combine these two things. So I need to combine x of 2 and x of 6, that gives us g of 2. Similarly, let n be equal to 3. So if so, g of 3 will be equal to x of 3 plus, what is the other data? So x of 3 plus 4, which is nothing but equal to 7. I need to combine x of 3 and 7. So here is my x of 3 at this point. So take this data and give it to this point, adding those two data gives us g of 3. Hope it is clear how we get g naught, g of 1, g of 2 and g of 3. Now the same thing I need to do for h. That is, let n be equal to 0. What happens to h of 0? H of 0 will be equal to x of 0 minus x of 0 plus n by 2, n by 2 is 4, which is nothing but equal to x of 4. That is, I need to subtract x of 4 from x of 0. Then I need to multiply what? Omega. What is the value of n? 4. What is the initial value of n which we have taken here? 0. To this term, I need to multiply this. So first what I need to do? I need to take x of 4, that should be subtracted. In order to subtract that, what I will do? I will multiply that with minus 1. So at this particular point, what is the data which we have? We have minus x of 4. For that, what I need to give? X of 0. So from this branch we are getting x of 0. From this branch we are getting minus x of 4. So which gives us h of 0. Before that, what I need to do? I need to multiply omega 4 power 0. After multiplying this, we get h of 0. Clear? Similarly, when n is equal to 1, h of 1 will be equal to x of 1 minus x of 5. Okay, so this becomes omega 4 to the power of 1. Again, what I need to do? Multiply x of 5 with minus 1. Give this x of 1 to this point, and from this branch we are getting minus x of 5. This should be multiplied with omega 4 to the omega. So the value of n is 8. So this is not 4. This should be equal to 8. So even this is 8. So this is 8. Okay. Gives us h of 1. Okay. So then if n is equal to 2, what happens? H of 2 will be equal to x of 2 minus x of 6 multiplied with omega 8 square. So n value is 2. So x of 2 is here. Feed this to this point. Multiply x of 6 with minus 1. At this point you have x of 2 minus x of 6. Multiply that with omega 8 square gives you h of 2. Okay. When n is equal to 3, what happens? H of 3 will be equal to x of 3 minus x of 7 into omega 8 cube. So x of 3 is here. Feed it to this point and multiply x of 7 with minus 1. So at this particular point, what is the data which you have? The data which we have is x of 3 minus x of 7. That should be multiplied with omega 8 cube. That gives us h of 3. Hope it is clear how we completed the first stage. So this is stage 1. Now I need to do the same thing for stage 2. So when n is equal to 0 in this equation, a of 0 will be equal to g of 0 plus g of 0 plus n by 4, n is 8, 8 by 4 is 2, 0 plus 2 is 2, so you get it as g of 2. Okay, that is in order to find out, so at this point we get a of 0. What I need to do, I need to feed g of 0, so g of 0 comes here. So feed that to this point, then take g of 2, so g of 2 is coming here. So this and this added together gives us a of 1. Similarly, if n is equal to 1, a of 1 will be equal to g of 1 plus g of 8 by 4 is 2, 2 plus 1 is 3. Okay. So g of 1 is at this particular point. So fed to this point, again g of 3 is here. So which is fed to this point gives us a of 1. Okay. Similarly, I need to perform for the lower term also. So if I perform for the lower term, so what I get? So these two signals will be combined and these two signals will be combined. So again these two signals will be combined by multiplying it with minus 1. Again this and this will be combined. So this is nothing but stage 2. So like this we can complete stage 1 also. This is how you can draw the butterfly structure with the help of this DIT FFT algorithm. So this is only for stage 1 and stage 2. So if we continue the derivation, we get for the final stage also. So the overall diagram for DIT FFT algorithm is as shown in figure, so which includes all the 3 stages. So with the help of this diagram only we will be solving problems and we will try to find out DFT with the help of DIT FFT algorithm. This figure is also called as butterfly structure or signal flow graph. So in today's class what we saw, we tried to deduce DIT FFT algorithm with the help of divide and conquer approach, and we saw how to draw the butterfly structure for DIT FFT algorithm. In upcoming classes, let us see problems on how to find out DFT with the help of DIT FFT algorithm. Thank you.